Well, good evening, everybody. This is Charlie, November Juliet 7 Victor, and we are ready to talk batteries tonight. Welcome to the All Portable Discussion Zone. It's a bi-weekly live stream all about amateur radio portable ops. So with me tonight is my guest, one of the co-hosts, Dan, KC7MSU. Brian is running late, and he can pop in a minute, and he'll let you know why he's running late. But with us are our two guests tonight, Dennis, AD6DM, and we have Mike, K8MRD.
Hi, everybody.
And of course, as always, we have the regular characters in the chat room asking questions and making comments and giving us a hard time. We welcome you as well. We're happy you could join us tonight. So this lineup tonight is going to be all about the power, batteries, and so we are looking forward to getting that discussion going. Let's go ahead and say hi to Brian, W7JET, and he can tell us what happened here just a minute ago.
So I was over at my mother's and stepfather's house helping them navigate online DocuSign, which if you ever tried to do that with people in their late 70s to 80s that still had rotary phones up until about 3 years ago, you can understand what I was doing for almost 45 minutes. And then on the way home, I noticed the voltage on my an alternator wind on my radio, and that my radio kept resetting every time the APRS sent. And I'm like, I think I have a voltage problem. And then boom, alternator light, alternator's dead. And then of course, got stuck at a traffic light. And well, yeah, that's when the computer decided to unlatch because the voltage, since we're talking about batteries, the voltage dropped low enough where the circuit's unlatched and the engine stops running. Because unfortunately, with a new vehicle with a computer control, it does not run without the computer anymore. So 2 jump starts later, I'm in the driveway now. My wife is running to AutoZone to buy me an alternator so I can put the alternator in after the live stream's over. So I'll be in the spirit of batteries. The battery is currently on the charger, so I'll have a fully charged battery by the time this is over with.
There you go.
That's what I was up to today. How's everybody else?
All right. Well, we usually kind of go around and give kind of a report of what's been going on the last few weeks. For me, it's just went out with the tech prepper, KD1RUN, yesterday it was, and we got on top of a peak and did some tests and SOTA operations and stuff like that. Other than that, it's just kind of been a quiet week. I think a week before I was out doing, the week before that I did Harquahala. That was a Jeep trail up to the top of this really high mountain, and it was a good time up there as well. So a bunch of SOTA stuff as usual, and not much more than that. How about we go to Dan, and then we'll get Mike and then Dennis.
All right. See here, since last time we were on, I went out and did usury peak, so that was a lot of fun. Enjoyed that. Spent about 2 hours or so up there, which was really nice. Started to pick out a new summit for heading up to Flagstaff next weekend, so we'll see how that goes, and hopefully hit at least one up there this coming up weekend.
Cool. All right, Dennis, what you got?
Nothing much going on over here. Nice sunny day in California. It's about 60 degrees throughout the day. Did some outside work, and I've been working on building a battery today. So
nice.
We'll talk about that a little bit in a little bit here.
Oh, cool. All right. What's it like back over there in your new neck of the woods there, Mike?
Well, now that the snow is gone, it was, I don't know, it's about 80 degrees today.
Nice.
I'm in shorts and a t-shirt. It's great. I woke up this morning, cleaned the house a bit, and then I played with my new Slink Tenna James Hannibal sent me.
Nice.
And just posted a video on that. So go to K8MRD radio stuff after this and watch that video.
Cool.
But other than that, I haven't been doing much with the channel. I just moved in like 2 weeks ago, so I've just been unpacking, and gradually the boxes are making their way up to the attic, and the space is kind of getting a little more cozy. So, but haven't played too much radio. It's been, crummy weather in Texas lately, so haven't had a chance to get out. But I have a new toy coming soon that will definitely inspire me to get out. Let's just say that.
Wonder what that is.
I don't Master of the tease. Okay, well, let's. The reason I brought you guys on, it's obvious. We want to talk batteries, and I just wanted to. I can't speak for Dan or Brian, but my knowledge of batteries is very limited. I know a little bit about it, and I can muddle along. But I thought if it's me that's I don't know a lot, then I'm sure there's a lot of other people out there. But what I wanted to do today was I wanted to talk a little bit from the perspective of a new ham getting a new radio and kind of what they kind of need to consider to to match their battery properly to their radio if they're going portable. But then we don't want to don't want to bore these people who know a lot more about batteries. So then we want to get into some of the meat of batteries as well, so we can kind of cover kind of both sides of that, the noob, and then some of the stuff that maybe some of the other people would be interested in. So I wanted to start off by asking you guys. We'll start with Mike. I wanted to ask you guys, what inspired you to get involved in and start learning about batteries to begin with?
Well, so a few years ago, when I first upgraded to my General, I started getting into portable radio. A guy, Jason W8ZZU in Michigan, took me out for my first portable operation, and I had been watching guys like Jerry KG6HQD and Kevin W6RIP, Tony K9ARV, and I watched them do all these portable things. So that's kind of always interested me portable wise, and I'd always see them have these little, they'd always have like an Elecraft or an 817 or something, QRP guys, and they'd have these little batteries. So I went out and bought, right when I got my 891, I went out and bought a Duracell, I don't know, 8 or 9 amp hour AGM absorbed glass mat or whatever it is battery. And it worked for I was just doing QRP with the 891 at the time. I made a little go box, and then I stumbled upon Julian OH8STN's channel, and I think Dennis and I are going to have a lot of similarities here. But I started watching his channel, and he's doing these battery builds with these lithium iron phosphate batteries, and then I started learning about how much lead acid kind of sucks and how awesome lithium iron phosphate is, not to be confused with lithium polymer, which is actually a bit smaller and lighter, but way more dangerous. So Julian did these builds with these headway cells, which are over my left shoulder here, the circuit board and stuff. That's the battery that he made. So I went and bought the cells and the BMS and wired it all together. And another guy, Will Prowse on YouTube, is big into lithium iron phosphate, and just like the power and the capacity and the kind of the prepper mindset, and the if power goes out, I can still have lights, and I can still have, I can power my computer. So batteries just kind of, it's like antennas, like, ham radio. A lot of guys are really into the radios themselves. Like I like them, but for me, antennas and batteries are really what grabbed me, and those are kind of the things that I really geek out about. Cool. So
yeah, geek out for sure, man.
Yeah.
Absolutely. We're going to get into that a little bit more. Okay, Dennis, what do you got?
Well, very similar to Mike. I remember when I got my 857, and like any ham, I just bought a power supply for it. But then I was thinking, I want to take this thing out. I don't want to just be at home operating this 857. So I bought a nice motorcycle battery. I think it was 35 amp hour, and that thing was heavy. I was just like, well, I guess I'm only using my car. I can't really carry this anywhere. Ended up buying a smaller 7 amp hour battery, also sealed lead acid, and discovered Julian's videos, much like Mike. And I was like, whoa, there is actually a lighter, more powerful setup, and you could actually make it yourself. And so I got really excited about that. I actually went a little bit overboard on my first try and bought the headway cells, the ones that Mike is showing behind him. And I just took everything that I was learning on YouTube and tried to cram it all into one case. and that ended up taking a couple months for a 15 amp hour battery, which I have. I'll show it here. This case that I have, and it's I have a relay in there, and it's got it's a little meter and all kinds of doodads, doohickeys inside to do solar charging. To I have every conceivable connector and cable inside here too, just in case I need to hook it up to different things. But that was inspired by Julian, so props to him.
Oh, I tried to get Julian on. He's just a busy guy, and I mean it was a stab in the dark, but whatever. Of course he was too busy, but maybe someday, right?
Yeah, he's a great guy.
Yeah,
and
cool.
Definitely, just everything I know, I think I learned initially from him. Also, Will Prowse. There's another guy named Jehu Garcia, who is
Oh yeah, forgot about him.
Ions and salvaging laptop batteries and things like that. All of that, I just kind of took everyone's ideas, and then after that, I learned how to simplify. So after my first thing, which I still use, and it's very capable, I've used it with inverters and different scenarios all over the place. Then I just started kind of narrowing down my focus and what I wanted to actually do with the batteries. And so that's when I started making QRO batteries, QRO portable batteries. So they're a lot smaller, but they're still capable of powering your 857 and weigh about like 1.5 pounds at most. So that's how I got started.
Cool. So let me just, I'm going to go ahead and ask this first question. I know it's going to take us down a rabbit hole, which is fine, but also Dan and Brian, you be prepared with this. I'm going to just ask this question, which may take us a few minutes, and then maybe you guys can throw in a few as well. We'll see how it goes. But the question is, I'm a brand new ham radio guy. I've been in the hobby a year, and 9 months of that has been as a technician. Just got my General, excited. Just got my newest ham radio. I just bought it, and I want to take it portable. Let's say it could be a mountain topper, or it could be an FT18, or whatever. It doesn't matter. So I want to power that thing, and I want to make sure that I don't blow up my radio doing it. So how do I decide, how do I match my battery with my radio? Where do I go to figure out what the radio takes and all that, and how to match it to the battery? So Dennis, you go first on this one and answer it, and then we'll let Mike interrupt you or go after you. Either way.
Okay. Definitely
Wrong.
need to know what the draw is. So whatever rig that you have, your first rig. Now, if it's a mountain topper, you need to be careful. So throwing that in there messes with the question a little bit, because you can't use these batteries that we're talking about with a mountain topper. They put out like 13.8 volts, and a mountain topper tops out at like 12 volts or 13 volts or something like
12.
that. So you have a potential of damaging a mountain topper. So
yeah, that's why I threw it in, because we need to talk about how to match those off things.
So LNR precision type radios, you want to stick probably with like something around 11 volts, which would be a lithium ion type battery, and they don't take much, so definitely use small capacity, very light. But if you're talking about an 891 or even a 7300 or something like that you want to take out in the field, then definitely you need to consider how much it draws. So that's on average, like my 857 draws 22 amps at full power.
So how do you know how much it draws? How do you know that?
I have little meters that will tell me that.
Okay.
I can't find it right now, but I have a little meter, and probably Mike has one that he can get, but they're just really inexpensive meters that you hook up to the power poles, from the battery to the source, to the load. There you go. One of those PowerWorks.
So Mike, real quick, tell the difference between that and the cheap ones, because I know there's a difference.
Yes, there is. Actually, let me get.
While Mike's getting that, let me just say one of the other ways you can tell how much draw your radio's getting roughly is you just look at the manual. The manual right at the front page, it'll tell you. So
Yeah. So that's I mean, obviously, read the manual is key, but
Who does that really?
well, I usually read it after I screw something up, but
Yeah, exactly.
I was gonna say you don't touch the manual until about 6 months after you own the radio.
yeah. I
Then
think
you
my
can't
891
look
manual is
quickly.
still sealed with the factory tape, but so no, but the here the 891 actually, Yaesu says that draws like 2 amps on standby, just sitting there on receive, which is ridiculous. It doesn't. And it's, I think they say about 22 or 23 amps, like full blown CW key down. But this is an inline watt meter and power analyzer. So this will actually cycle through. One here. I'll just plug it in. So it'll cycle through. It'll show your voltage. So we're at 13.43 volts. And then this down here that's cycling will show you how many watt hours you used, how many amps peak you've used, how many watts peak, and how many amp hours you've used. So you can, and then up here under the, next to the A, that's if I had a load, that would tell me how much current is being drawn. So like if I plug my 891 into this, it will say straight up 1 amp is being consumed by the 891. So these are great. And then when you key up, stupid camera, the this will go up to, you know, whatever. So usually like on sideband at 100 watts on the 891, this will peak about 12 or 13 amps because sideband is, you know, it's still amplitude modulated. It's not a constant carrier type thing. But this PowerWorks one is fantastic. It's like $60 though.
Mhm.
But I have 5 different ones of these. I've only got one PowerWorks one, and then I've bought different. Like this is, I think, GT Power from Amazon or eBay. They're like 15.
yeah, that's the one I have.
Bucks somewhere in there. They're not accurate at all. I mean, they're close-ish, but when you're out in the field and you want to actually measure your current and your amp hours and stuff, you kind of want it to be accurate. So yeah, I mean, that's why they're 12.
Okay, so here again, I'm trying to make sure that people who are new to the hobby can understand this. So you say get this meter, but I mean, if you don't have a battery yet, how would you use a meter to measure the draw?
Well, so you can hook your radio up to a power supply,
Yeah.
Your 12-volt power supply, and then put that in line, do some tests to see, you know, if you're like the rest of us and you don't read your manual, you just want to see, like, I'm a show me guy. I'm not like, I don't want to read something. I just want to, you know, show me. So hook this up to put this in between your radio and the power supply, put your radio at 100 watts and CW and key down, and that's going to be the max. You'll see the max current that your radio is going to draw.
Cool.
So that's how you would basically figure out, and there's math you can do depending on the duty cycle and how much you plan on transmitting versus how much you plan on receiving. BioEno uses like an 80-20, 80 receive, 20 transmit. I say throw all that to the wind and go 50-50 duty cycle. Because when I'm out portable, you're running a pileup. It's like, I mean, you're nonstop. It's just, you know, you're 5'9", thanks, 73, K8MRD, POTA, QRZ, you know, so
Yeah.
that number goes down a lot. Going down that rabbit hole.
Okay.
Math is hard. Yes, it is.
Right,
Yeah.
right.
Yeah.
But what I did, because I didn't know much when I started out, was I just went on forums and I would ask similar questions. I would say, how much does the 857 draw at max power? And then they'd say, oh yeah, it goes 20 to 22 amps max. And then I would just figure out my batteries from that. Like from that baseline, like, you know, I didn't even consider duty cycles and all that. I'm just like, what if I held the key down? How long would I be able to keep this radio on? And so from there, you can scale back, of course, but I wanted to know what a battery was capable of and what the right size was. And so after a while, I figured out that, yeah, with a 6 amp hour battery that's lithium iron phosphate, I could probably put maybe an hour or so, maybe 2. And that's good enough for contesting or just going out there and making contacts. Now, if I wanted to go longer, then go to, 12, 14 amp hours, or maybe 20. But I haven't been in a situation where I've done that for that long without some supporting things like solar and other things to help pump up that battery life.
What about what they publish in the actual manual for specification versus what you guys have measured in the past for various radios? Are they close, or are they not even in the ballpark?
I think it's a little overestimated in my case. They said 22 for the 857 when in practice, I only saw it go up to maybe like 19 or 20 at most. And that's CW holding the key down. I mean, unless you're doing digital, you're really not going to be using the full power of that transmitter.
Yeah.
If you're doing FT8, then yeah, you need to consider what the max will be, because you're turning on your radio for 15 seconds at a time or something like that. Okay. But Mike mentions BioNO. Maybe people don't know that, but BioNO is a supplier of really great batteries that are all pre-made.
Yeah, you know what? In fact, I actually reached out to them and told them that I just switched over from the LiPo to the LifePo, and I just got my BioNO battery, and I used it for the first time on my last activation. I'll have a video about my transition here pretty quick. There's Brian's as well. That's the site. I have a 4.5 volt. They're right there. Yeah. Endorsed fully by all of us, I think. Unofficially.
Yep, love those.
Another one.
Yeah.
Yep, I got two of them. This one's the well-seasoned one. It's been around the block a few times.
Actually, Brian, I made one like that myself. I kind of copied their design.
Yeah, but we're gonna get into that, aren't we, Dennis?
I actually sent one to Charlie.
Oh, I love it. It's a what is it? A 2 amp hour you sent, or a 1 amp hour?
3 amp hours.
Yeah. Cool.
But yeah.
All right, let me just wrap up or summarize then for the new ham, and then we'll dive in a little deeper. So, for summary, then check the manual, see what the voltage limit is, and see what the draw or the amps are. Make sure that your voltage is matched with the voltage on the battery, and that really only matters with like the MTR3B and stuff like that. It really doesn't matter. It pretty much is standard 12 volts for everything else, other than some of those specialized. Then for the amps, you just gotta do the math on what the manual says, or what you see in the draw, as far as how long you want to operate, what the size of the battery is. Is that right? Yep. Pretty much in a nutshell.
Yep.
Okay. Good. We can move on then. I hope that helped some of the new guys. All right. Any other questions, Dan or Brian, before we move on to some of my other questions?
Yeah, I've got one. So say I've got an old BioNO here. It's been used for several years. How safe is it for me just to crack that thing open and see how they put them together? What's the risks and stuff?
Insanely safe. Yeah. Lithium iron phosphate is very, 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 very safe. It is not to be confused, like I said earlier, with lithium polymer, where if those cells start to go bad, they puff up. If they puncture and they get exposed to air, they violently catch on fire. Lithium iron phosphate does not do that. Someone in the comments said have a bucket of sand when you're working with these. That is not the case with this kind of battery. This is incredibly safe. I've seen videos of guys puncturing these with crossbow arrows and stuff, throwing them in fires. They're not like the other types of lithium batteries. So yeah, you don't. That's why so many hams are using them and building them, because they're safe. If it was lithium polymer, you got to put those in a bag. It's like a fireproof bag to charge them if you want to be safe, because like you're just charging them, they can just blow up. Like those Samsung phones on the airplanes, they were blown up.
Yeah.
Well, all I can say to that is you've obviously never seen me work in my lab there, Mike. So
I've seen these overcharged to like 2 or 3 times their voltage, and they still don't. I mean, you can beat the crap out of them, and they won't do anything. I mean, they'll leak and they'll gas, but
where they would intentionally short positive and negative and see what happens. They vent, they get very hot.
Yeah.
So you could burn yourself, but
and
you're not going to explode violently like lithium
Mhm.
ion. So that's why I use them. I definitely prefer. I mean, they're bigger, they're heavier, and they don't hold as much power as lithium ion, but you do get that safety factor of
So-
them.
So look for the FE inside in the name of it. Is don't go for the LIPO, go for the LIFE. You want life, right?
Yeah, life.
Yes.
As I say, I used to I'm also an aircraft mechanic. So back in the day, we used to, it's not as common now, but we used to have to service and maintain aircraft NiCad batteries. And we used to keep a very large 55-gallon drum full of sand to shove the battery into if it started running away when we were doing the cap checks on it, because that was a real reality with those batteries.
Okay, let's see. Next thing I wanted to talk about was, well, I don't know. There's a lot of different things. Should we go over some of the questions, Dennis, that I had?
Yeah, let's do it.
All right, let's take a look at some of them. Probably easier for you to pull it up than me, but okay. What's the difference between a LifePo and a LifePo 4?
I think you meant lipo versus LifePo 4, right?
Yeah.
I think so.
Say yes.
We talked about that a little bit. Lipo is definitely consumer electronics have them. They pack a lot of punch. They hold a lot of energy for their size and their weight, but they are quite angry if you mess with them. So if you stab one, you will get a nice flame explosion.
I guess I think I must have read. What's the 4 for the number 4 on the end of the name?
I'm guessing that means phosphate.
Oh, okay.
The element
I don't know.
phosphate.
Those
But
zippy
really,
batteries
people
that
call
you
those-
use are lithium polymer.
Yeah.
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 They call them lithium ferrophosphate sometimes. So that's
Yeah.
why the Fe is in there. Ferro is iron. So lithium iron phosphate.
Okay.
And that's just the chemistry that is used to, have the charge.
Yeah.
I can't get more specific. than
Well,
that.
let's talk about maintenance then. Do you have to make sure that the LiFePo batteries are discharged to a certain voltage before you store them, like a LiPo? Can you? I mean,
No,
like
okay.
if you're going to store it for 3 months, maybe, do you have to do any type of maintenance on the LiFePo?
Not really. So lipo is pretty temperamental. I think, like for example, my drone, it will self-discharge to 70% if I don't use it in a certain period of time. Whereas I've had fully charged lithium iron phosphate batteries in the garage. I have cells, in fact, that I bought in 2019 that I'm just now putting to use, and I'll measure the voltage, and they're perfect resting 3.2 volts, like nothing happened. So I think lithium iron phosphate, there's nothing like memory or anything like that, like from NiCad or.
Well, so you could actually fully discharge it and then set it on your desk and not come back to it for a while and then charge it right up again, huh?
The only thing with lithium iron phosphate that I've noticed is like I have a lithium iron phosphate battery in my motorcycle, and parasitic loads on those will run them down to the point where they'll just shut off, right?
Mhm.
So you just need to make sure, and it's also happened with my Go box for my 857. Some little drain will actually deplete them, and then you'll just find one day that they seem like they're totally dead, but you need to just kind of give them a little shock, and then they will wake up again, and you can charge them again.
Okay. Give them a little shock, huh?
Yeah, a little jump start.
Okay.
It wakes
That's
up. the
BMS
BMS.
related, though. That's the circuitry that's inside the
Yeah.
either BMS, which is battery management system, or a PCM protection circuit module. Now I'm going to argue your point a little bit, though. Bioenno recommends, if you're going to store them long term, discharging them, I believe, to 50%. Don't quote me on that. Maybe 75%. They say discharge them a little bit if you're going to go long term storage.
Okay.
Yeah.
So, but I
It only
mean,
helps.
I charge mine all the top when I get back from my POTA activations. They sit on the shelf.
I'm
So I
pretty
definitely do
brutal.
not do that.
Yeah.
Yeah,
So
I'm
what do you guys both do? I mean, as far as is that what you do then? You use the battery whatever however much you want, drain it as much as you want, then top it off and set it aside till next time?
Yep.
Yes.
Yep.
The
And now
thing-
if you want to baby your cells, you should really kind of, like, I charge mine to 13.65 volts, which is like the max that they will take. If you really want to kind of baby them, maybe charge them to like 13.6 or so. And I never come close to discharging them to what would be a damaging level, because the protection circuit module prevents that from happening. It shuts off around 10 volts.
Yeah.
So each cell, I believe, like 2.5 volts you have to get to before you start to ruin them, where you'll get some cell degradation, and you'll never go that low with a PCM. So
Right.
I do want to point out though, so lithium ion or lithium ion or lithium polymer have less charge cycles. So there's about 300 to 500 charge cycles on consumer electronic batteries. So, but lithium iron phosphate, and the reason that I'm so abusive of mine is that they last 2,000 to 3,000 or more. If you baby them, you can go more than that.
mhm.
And I figure by the time I reach 2,000 cycles of charge and discharge, I will have found a better battery technology. So why do I need to baby these things? I'm just going to charge them to full every time I use them. I've discharged them down to 2 volts per cell before, and then I would just, wake them up again and recharge them, high current charge. And I have batteries here that have gone through a lot of pain from my use cases, and definitely I figure, okay, if I screw this thing up, there's going to be something better and cheaper that I can put together.
So this is how I carry my LiPo batteries in my backpack.
Yeah, there you go.
Nice.
But this battery that I have in here, I actually have 2 in here, but the one that I have here, this one is 6 years old.
Mm-hmm.
And I figured it's about ready to blow up at any moment. So that's why I switched over, because I think the lifespan of these is usually around 3.
You'll see it start to
Yeah.
bubble, like
Yeah.
I don't know, like start to puff out a little bit.
Yeah.
That's what happened with mine a lot of times, is they'd start puffing up. So
They wouldn't last for long. I had one
Yeah.
I had for like no exaggeration, maybe 6 weeks, and maybe like a half
Wow.
a dozen activations, and it started swelling, and I'm like, yeah, it's time to get rid of this.
Yeah. Then you would need your sand, but not with lithium iron phosphate.
Yeah.
Yeah. Listen. Okay. So let's ask another question here for you guys. Battery. I don't know if it's performance as much as characteristics. So we've got the AGM, the lead acid, the deep cycle, and then we've got the LiPo and the LiPo, and we've got the nickel metal hydride. There's several different types. What's the characteristics of each of them? As far as I know, for example, I started out with nickel metal hydride for my FT817, and I always wondered why I got more contacts at the beginning of my activation than I did at the end. And the reason was because the depletion kind of goes it just kind of goes down steadily, right? So that's kind of what I wanted to talk about next. We've got all these different types of batteries. What are the characteristics of each of them?
I'll hand that over to Mike.
Oh, I was going to try and find a graph, but that's okay. I'll answer it. I have it somewhere. So I don't know much about nickel metal hydride other than they're like every AA battery rechargeable that I have. But I would assume their characteristics are similar to like an AGM or a sealed lead acid battery. So the voltage with a lot of batteries, I suspect lithium ion, like lithium polymers, would probably be similar to LiPo4. But basically with a lithium iron phosphate battery, you're going to start, they actually charge to about 14.6 volts, and then they settle down to about 13.4, 13.6, 13.2, depending on what kind of cell it is. And then they're just going to stay there. So you start your day, you start your activation, and your meter says, let's just say 13.3 volts, and it'll just stay there the whole frickin' time. So looking at voltage with lithium iron phosphate is the absolute worst way to see how much capacity is left in your battery. where a lead acid is going to start. They charge up to, I think they charge about 13.3 and settle down like 12.8, something like that.
Yeah.
And they're just going to immediately start going down, and
Yeah.
it's just it's like a plane crash,
Mhm.
where lithium iron phosphate is just going to go steady, and then at the very end, it's just going to, I mean, it's just going to dramatically
Cliff
fall
dive.
off a cliff. Yeah, I mean, like you look at a graph and it's just so. But capacity is another thing. So like unless we're talking about deep cycle batteries, which are different, but with a lot of the sealed lead acid batteries that we use in amateur radio, say you have a 10 amp hour lead acid battery. Well, you're actually only going to get 5 amp hours out of that. They kind of lie. I really feel it's false advertising, because if you go, once you drop below, gosh, I think 11, maybe 10 and a half volts on a lead acid battery, you have started to damage the cells in an irreversible way. Like you got to be careful with them. But they also, you can't pull, they have a voltage sag. So the second they get a load, that 12.8 volts is going to go down to like 11 and a half. So you won't get that performance out of your radio either. So there, I mean, there's all kinds of reasons. I mean, if you're doing QRP, a little AGM battery is going to be fine for you, but they're just not that efficient. They have the capacity of whatever it is. If you got a 5 amp hour battery, well, you're only going to get 2.5 amp hours out of it. But then with that voltage sag, they're not good batteries. They suck and they're heavy. So
Okay.
They're
Dennis?
cheap, but they're not that.
Yeah, they're cheap.
great. So in the long run, you pay for that.
Okay.
But yeah, that's a good point about the curve. It just kind of cliff dives at the end, and you're dealing with a pretty reliable chemistry for, like, I think it's 90% of the capacity. You will have that consistent voltage. It'll drop a little bit, and then it just kind of nosedives. And I noticed that too when I was carrying around those big motorcycle batteries. I was like, what? This is supposed to be 35 amp hours. Why is it dead already? And I'd always be shocked.
Yeah.
So, yeah.
Well, you mentioned the deep cycle batteries. How much do you know anything about those, and what the deal is with those? Then either of you?
They're just ridiculously heavy. So like marine batteries,
Yeah, that's what I'm using right now.
You'll get the capacity out of them. I believe, I haven't really used them, but like, you use them for trolling motors on boats and things like that too. And I believe they've got a high like discharge current. You can pull a lot of amps out of them. They're just kind of made for that. But
Yeah. So
holy crap, are they
I
heavy?
wanted to interject. Scout75 asked a question in the chat.
Yeah.
He says, I'd like to keep lithium iron phosphate battery full time in a vehicle for POTA, MCOM, etc. Would a winter cold snap, negative 20 degrees Fahrenheit, damage the battery? Obviously warm up before using. And the answer to that is yes. Typically, lithium iron phosphate doesn't like being used. Like, there's different temperatures for charge and discharge. And I think charging, the lowest you should safely charge a lithium iron phosphate battery is around freezing, around 32 degrees Fahrenheit. And then discharge, I think it can go to like negative or to 0 Fahrenheit. Don't quote me on that, but
That's good to know.
there are different.
There's
facts.
mixed results on that, because you hear a lot about definitely the charging temperature. But I interviewed Kevin from Bioenno and talked to him about that, and he's got his batteries. They sell their Bioenno supplies batteries to the government, and they've got stations where Bioenno batteries are in freaking Arctic, and they charge. And I'm like, you don't have any concerns about charging or discharging in those extreme cold temperatures? And he's like, no, not at all. So
That's good to know.
yeah, I mean, I would trust Kevin a little bit more than I would trust Will Prowse. Will Prowse is very big in like, there's no low temperature cutoff sensor in this.
Exactly.
In terms of like using them while they're cold, I don't have any concerns whatsoever. But still, I mean, I would keep my Go box in my car in Michigan, and it's
Yeah, to
0
me,
degrees. It's
I'd be very hesitant to use a battery that's been sitting in -20 in the trunk, just from a cold start and
maybe
start
sit on it for
using
a little bit.
Use something to warm it up a little bit. But again, yeah, that's kind of transferred knowledge from Will Prowse. I don't know in reality. I just wouldn't risk it personally.
Yeah.
While we're on the we're kind of on the topic anyway. And another one of the questions I had is speak a little bit to what the approach one would take in acquiring a battery for SOTA versus POTA, because I think there's even a difference there in how and what you would consider and how you would what battery you would choose.
Mm-hmm. Well, I would say for SOTA, you're packing light, right? So
Yeah.
despite what you bring, I know I went with Rex on a mountain once, and he brought his 891 with him, but he still brought a very light battery, despite it being a QRO rig. So you don't want to be bringing pounds up a mountain, but on the other hand, you got Mike who takes his 7300 out. So you want to bring a big battery with that. And with POTA, at least, it's in your car and you don't really have to take it up, 2,000 feet elevation gain.
Yeah. Not a lot of hiking. And well, I suppose there can be a lot of hiking in POTA, but when you park your car and walk 100 yards to a bench, it's a little bit easier.
That's part of the reason that I may make my own batteries, is that I haven't found a good balance between something small that can put out a lot of amps. I know that BioNO, Mike talked about this in one of his videos where he had, some limitations on some of the smaller batteries he had, but then he talked with the guy at BioNO and they said, oh yeah, I can handle it. We're just conservatively listing that it should be a little bit less of a draw. Yeah. I actually, when I make my batteries, I make sure that they can handle QRO, and that's with the choice of the components, the BMS and how much it can output, and the cells themselves and how much they can output. And so,
let's talk about that a little bit more, Dennis.
Yeah, that's pretty much how I size my. I haven't found a good, other than BioNO, which I could probably draw a lot from. I haven't really found anything small, so I started making some of my own, and in fact, I can switch.
Yeah, let's talk a little about how, because you make your own battery. Do you make them too, Mike? Do you make batteries?
Yes.
Oh yeah.
I should know this, but I don't.
The one with that one.
Yeah, there you go.
With the circuits, I made that.
Okay, so let's talk about how somebody would get into making them then. Where you source your parts, kind of how the approach you take, all that kind of stuff. Let's see what Dennis has first. What's that?
Yeah.
So this is actually a little pack that I've been working on today. It is actually about 3 amp hours. And these cells are crazy strong. They can actually output, I think, 100 amps each.
Wow.
So if you're going to put together a battery pack, these are 3.2 volt cells, and there's 4 of them in series. So that totals about 13, what was that, 13.2? No, is that right? 12.8 nominal, 13.2 fully charged. And so I put a BMS on here that says 4S50A, 3.2 volts. So that's 4 series, 50 amps capable of putting out there. So if I hook this up to my 857, it would have absolutely no problem. I could probably hook up 2 857s to it. It wouldn't last long, maybe about 10, 15 minutes at full power. But it could actually handle that kind of load. Again, these batteries I got from batteryhookup.com, and the BMS I got from AliExpress.
What are those black things that are holding it together? Where'd you get those at?
Those are little holders. I found those on eBay for this size of battery. This battery cell is called a 26650. It's that describes the dimensions. So it's 26 millimeters in diameter and 650 millimeters in length. And so you'll see different sizes. You'll see 18650, which is a very popular one. Those are typically lithium ion cells. You'll see 26650s. You'll see 32650s, which are these, a little bit bigger. And that's how you figure out which kind of holders you need. These are 3D printed holders. But In this case, I'm trying to build small packs, but this one packs a punch.
Yeah. So what are all the pieces then there? You've got the black holders, you've got the batteries themselves, and then you've got you said a BMS, right?
Yes, and then of course you need solder, you need flux. So
And then something to
things.
solder and
Flux
okay,
pan, my
flux.
solder. You need nickel strips.
What are those
Right.
for?
This is for connecting each of the parts for making it in series.
Okay.
So if I turn it around here, you can see how I did it.
Okay. And then what? Then after all that, then you shrink wrap it or something?
Yes. I don't have the shrink wrap available here, but I can show you one of the cube configuration ones I have that you just kind of, you size it by figuring out what the height and the width is, and then you just double that and then add like 10-15%.
Yeah.
And that's how you know it'll be big enough for the battery pack you're making. It's just Google PVC blue shrink wrap and you'll find different sizes of this wrap. Like I'm probably going to use the same size for this pack. It's just flatter but it's the same dimensions essentially. And then you use a heat gun or a hair dryer if you don't have a heat gun, and it will just kind of conform and wrap around the thing. And this stuff is actually pretty strong. It actually hardens the battery quite a bit.
Can you speak to soldering versus spot welding the nickel strips on?
Yeah, I started off soldering, and you always run the risk of damaging the battery if you keep the iron on those terminals too long, but I've never actually damaged them. And probably my first 4 or 5 batteries, I didn't have any kind of spot welder. So I did solder them. Now I have this little car battery spot welder, which allows me to do it very quickly and very little heat transfer to the batteries themselves. So just like any electronics, you want to just be careful with heat on things that hold electricity, right? So you could easily, if you just left the soldering iron tip on a chip, you could fry that very easily. So it's the same kind of precautions. But in practice, I've never destroyed a cell because I would get it soldered before it got really too hot.
What do you have to add, Mike?
Nothing.
Nothing.
He did everything. No. So he's taken the battery building way farther than I have. Let me turn my background off here. But so he's like welding and stuff. With this is the battery that I built. With these are Headway is the brand, and these are 38 120 cells, so 38 by 120 S meaning screw terminal. So the configuration is exactly the same. You've got 4 batteries in series, and then these little bus bars where he is welding them. These just screw together and then connect them all. So same idea. This is the BMS. This is a 30 amp BMS. I could have gone higher, but I'm like, when am I ever going to pull more than 30 amps out of this? So, and I still have never to this date needed to pull that, but I can pull, I think I can pull 100 amps out of these as well. These are probably twice the size of the batteries that Dennis just showed us in terms of physical size, but because we're 3 amp hours, this is a 10 amp hour, so obviously there's going to be a little bit of a size difference, but pretty easy to, just go watch Julian's channel, OH8STN. He's got a ton of videos on how to build this specific pack. This is what started it all for me. And then just because I can, I want to show off my Denko battery.
Nice. Mine's up here. I'd have to.
This is a battery that Dennis was kind enough to make for me. It's got a little voltage meter on there. Ooh. Yeah, it's awesome. A USB and 2, because he knows what a power pole nerd I am. 2 power pole leads. So the blue one is for charging, and the red one is for the discharge. So yeah, this is awesome. And then these are what kind of cells are these? You can kind of see.
They are they're called Litokala They're spec to be 7 amp hours, but in practice they're about 6.5.
You lied to me.
But the reason I put the 2 power poles there is I like the ability to charge while using.
Yes.
You don't see that too much in batteries these days.
Well, the Bioennos do.
Yep, they do.
Yeah, they do that. It's very easy to just put a pair of leads to the BMS and the terminal, and just have something that you use, and then you stop, and then you charge it. I wanted solar to come into play, so I wanted solar charging my battery while it's getting full use. And so I'm pretty sure that Mike wanted to do that too, so added the extra set of power poles so he could use his mini solar panels with the battery at the same time.
That's pretty cool.
That's awesome.
So can I ask real quick? I mean, you don't have to. I guess the best way to ask it is, what percentage of savings do you think you get, if any, from building your own batteries? So I was going to ask how much did they cost, but maybe it's better to just ask what percentage of savings do you think you get?
Well, my 10 amp hour battery cost more than a Bioenno 20 amp hour battery, sort of. Because I bought the cells were about $100 from China, but then you had to pay shipping. And then I bought the BMS that was about $50, and then you pay shipping. So per amp hour, it was definitely way more expensive to build this one. Now, Dennis's cells might be different. He's ordering from AliExpress and he's ordering in bulk. They're pretty cheap to buy, but for me, it wasn't about the cost. I wanted to learn about batteries. I wanted to do this. I wanted to build it, just like you build your first dipole to learn about antennas. It's the same thing.
What better way, right?
Yeah.
I actually made a blog post on my website about this, because every time I'd show a battery on Twitter, everyone would ask me how much did it cost to do that. It comes out to around $30 to $35 per battery that I make. But that's not including all the other things that you need to get to be able to make them quickly, like a spot welder, all the power pole connector, or crimper, and you need a soldering station, you need multimeters, and all these other things that support what you do. If you already have those things, then excellent. But just the parts comes out to about $30 for the bigger
just
packs.
The parts. Yeah.
And then, of course, the time takes me about 2.5, 3 hours per battery to make them. The smaller ones, probably a lot less, maybe about $20. Now, if you go on a commercial site and look up these capacities, like a 6 amp hour battery or a 3 amp hour battery or a 14, 15 amp hour battery, you'll see that they cost hundreds of dollars. So it's a significant savings. And I told Temporarily Offline, when he was talking about this with me, it's about half the cost, but it's actually more than that once you have all the gear. It's about 30%, I would say, of buying commercial.
Well, what about battery management units? How do you know which ones are good and proven and stuff like that? Are there favorites out there?
We don't know.
If they smoke, they're bad.
Yeah, but almost everything smokes in my lab, so it doesn't matter, right?
Really, I'm going by testimony of others who've done it a lot. That's how I know which ones are good or bad. But I see some specs that I like, and I'm like, if it really does that, that would be awesome. So I just buy like 5 of them, and I mess with them, and I see how they perform. And just today, I released the magic smoke on one of them because I wired it wrong. But if you want something that's quality that a lot of people have talked about, I would recommend like Dali BMSs, but those are for really big installations. I have one right here. This is kind of an older model, but this is a 100 amp hour BMS. You could tell it's got a case, heat sinks, and it's ready for action, right? But
is that Dali, DALI?
DALY.
What does that thing usually run?
This, I believe, is around $40 now.
Oh, okay.
Or
That's
maybe.
a lot less than I expected you to say.
I mean, there are some, like I ordered one that does 250 amps recently, and I think it was about 100 and something, 114, I think it was.
So I have a question. So if you build, let's say you build a 100 amp hour pack, and you're going to go to charge it. What is the normal charge input voltage on that? And if I missed it earlier, that's sorry,
No,
but
we didn't talk about that. But yes,
okay.
it's the cells typically like around 3.65 volts each to to charge. If it goes to 3.7, that's kind of the cutoff. That's like the overcharge voltage. BMSs actually decide that.
Okay.
Because they will typically balance at 3.65 per cell. And before
So what kind of voltage are they looking to see?
Total voltage about
for input?
14.6 volts for input. I know that there are some chargers out there that do like 14.2, 14.4. Those are great. They're fine. They're safe. But because I'm building these myself, I know that the trigger voltage for balancing the cells is 14.6. So that's why I always look for chargers that do that. I've seen people use the lithium ion chargers that go to 15 volts, and that's fine too. The BMS will handle that. It'll just say, oh, that's too much. I'm at peak, cuts it off. They're pretty safe with that. But if you're just dealing with lithium iron phosphate, then definitely 14.6 is your target input voltage for charging. And then Mike has this fancy schmancy thing.
Yeah, we want to talk about that. But I was
red charger, right?
Yeah, where did you get? Talk a little bit. But I know you have a video about that. Tell us a little bit about that.
My charger.
Yeah.
Let me grab it real quick. Hang on.
Okay, while he's doing that, Dennis, BMSs versus power converters. Is there a difference?
BMSs, battery management systems, typically will balance. Mike also mentioned protection boards, which basically cut off at under or over voltage. But BMSs make sure that each of the cells are within a close range of each other, so you're not pumping more energy into the lower cells while one of them is like way above its tolerance and then damaging that weak cell. So it kind of manages the whole thing.
Right.
Power converters are just raw voltage. There's no protection. There's no short protection or overvolt or what do you call it? Yeah, over voltage protection.
Well, let's talk about power converters, and after Mike shows us his thingy and promotes his video about wherever it is.
Show and tell. So this is a high-tech HITEC. Oh, I don't know what model number it is, but it's pretty neat. You can't see the screen, so there goes my demonstration. But because it's really bright, there we go.
There you go.
So you can. So this will do many different types of chemistry, and I can change basically all the settings. So you can see it's 4 cells. The mode is charge. I usually only charge my batteries at 1 amp in terms of current, just because. And then let me see, go down. You can see the target voltage is 3.65. That's per cell. So it charges to 14.6 volts.
So that's for lipos as well. You have to charge them the same way as you do lipos then, huh?
I have not charged a lipo, so I'll take your word for it.
There's a slight difference.
Okay.
I think the target voltage for lipo is 4.2.
Yeah, other than the voltage, it's pretty much you have to basically know the cell number of cells and then how much amperage you're gonna put into it, right?
Yeah.
Yes.
And like all of this is configurable. So like if I wanted to charge it to if I want to take it easy, I can set the cell voltage. Maybe I want to only charge them with 3.6 volts per cell, but I don't because I'm very hard on my equipment. So just go big or go home. So that's what I use. I love this charger. It's fantastic.
Very nice
it
charger.
has like there's balance leads here. So if you don't have a battery management system on your cells, you can still connect it with this. They just be wired up to the cells and then you can connect it to that. But
yeah, I think that's my next purchase.
It's a nice charger. It's about $65, I think. I got it at an RC store. I walked in there. I'm like, I need a charger for lithium iron phosphate, and they looked at me like I was crazy because they all use lipo.
Yeah.
Like those zippy batteries were all over the place in there. And they're like, well, how big's the battery? I'm like, it's just a tiny little 10 amp hour battery. And then I went and brought it in. He's like, holy crap, that thing's huge. Because the lithium polymers are smaller. But yeah, so that charge is fantastic. But I also have, I don't know where it is. Here it is. Just this is the one you get from BioNO. This has been customized by me, but this will do like 2 to 4 amp hours of current. And it's just a red light, and when it turns green, it's pretty much charged, and that's it. So, and this is like $20 from BioNO.
Yeah.
So
that's the easy way to do it.
Yeah.
All right. Well, what about the power converters then? What do we need to know about that? And then the last topic after we do power converters is solar panels and stuff like that. If we have time, what's your time frame, Dennis and Mike?
I'm good.
We burned through an hour just like that.
I know,
Yeah,
right?
I'm fine.
I knew that this would go an hour very easily.
Yeah.
There's
Okay,
a lot to
cool.
talk about.
Let's talk about the power converters then, I guess, next. What do we need to know about that?
Well, I know that Luke Skywalker wanted to get some at Toshi Station, right? The power converters.
Wow, I gotta go.
I don't really know the context of the question, because I just know for my personal use, I have, so you have your auto, right? It's 12.6 volts or something like that, but that's not enough to charge a lithium iron phosphate battery. So I bought a power converter where you could basically boost the current and the voltage, or the voltage, not the current, up to 14.6. And then I would just hook that directly to the charge port of my battery. And so using the built-in auto system lead acid voltage, I could get 14.6 volts and then turn that into a charging voltage for my batteries.
So a buck boost converter, basically.
Yeah, I guess the context is, what about like 5-volt devices or 12-volt auto? Using different things and different batteries, you've got to have power converters a lot of times, right?
Oh yeah, okay. So in some of the batteries that you can buy, or even ones that I make, I put USB modules on there. So I'm basically buck converting 13.2 down to 5.2 for USB devices. Those are very inexpensive modules that you can add to almost everything.
What's that, Mike?
Yeah. That's a power converter.
And there's one right there. Okay.
Microphone. It's a buck converter from Drok, D-R-O-K, and it was like, I don't know, $10 maybe, and you can go anywhere from 36 to I think maybe 5 or 6 volts or something, and it'll drop down the voltage from whatever it is. So that's a neat thing.
Yeah.
But I've also just gotten, so like I wanted to just have USB, so I went to like Walmart or something and bought for a car, like it's got a cigarette lighter plug to USB, and it had a cable. So I just cut the cigarette lighter plug off, put power poles on it, and I don't know where it is because stuff is still packed away. But the USB thing inside does the 12 volt to 5 volt conversion. So now I can plug a USB into my iron phosphate batteries.
That's what I ended up doing too. Just split it off and just take these simple things. You can buy all that down at the local auto store.
Mm-hmm.
And you just put a power pole connector on there, split it out, and you're all ready to go. It's a little bulky, but I like Dennis's idea of having the USB built right into the battery pack. That's pretty nice. Then you don't have to carry extra stuff.
One thing I want to mention is that most consumer 12-volt devices are okay with lithium iron phosphate voltages, and that's why it's such a favored type of battery. Because if you're dealing with lithium ion, you normally are getting like 16 volts out of those things, and it comes down from there. Whereas lithium iron phosphate is almost like a drop-in replacement for sealed lead acid. So that's why it's so popular. The voltage is very, very similar to what devices are used to. So if you have a 12-volt lamp or something like that, or a 12-volt mini fridge that you put in your car, lithium iron phosphate is well within the range that those devices are used to having. And so you don't really have any conversion that you need to do.
All right. So what's your involvement, or I guess your experience or your experimentation with solar? I mean, there's a lot of aspects there. You've got what you might take backpacking, if anything. I tried to get Gaston on here. I sent him a text and a few other messages, but he, I guess, is unavailable. But
The tech
yeah, the tech prepper. But have you had any experience with solar, and if so, kind of what have you had, and what's the practical usage? Mike?
Yeah. I have, well, shoot, you can see right behind me. There's a big 100-watt solar panel from Rich Solar, recommended by Will Prowse.
That's awesome.
And then I've got, well, there's a couple solar panels in that box somewhere. And I've got 4 different BioEno solar panels, and charge controllers and all that. So yeah, I've been experimenting with solar a bit.
What all do you need to? I mean, I didn't know this until I knew it about 6 months ago or something. I learned this, but you can't just, it's not just cellular to, or I mean, solar to whatever you're trying to power, right? And
so a solar panel is going to put out like 21-ish volts, just from what it gets to the sun. So then you need something to convert that voltage down to whatever you're charging, but also for what type of chemistry you're charging. So you need a solar charge controller. And if you have lithium iron phosphate, you need a solar charge controller specifically for lithium iron phosphate. And there's plenty on the market. Genasun is a company that makes them that's pretty RF quiet. BioEno, here's a BioEno one that Dennis sent me. Thank you, Dennis. This is the, I don't know what model that is, but you can read it there. 12 volt to 12 volt, 24 volt, 20 amps. So you can pull 20 amps out of this. And basically this steps the voltage down, and it produces a constant current and a constant voltage, which is what lithium iron phosphate wants to see. This is very RF quiet.
That's what I was just going to ask you. How RF quiet are those?
Those are fantastic. This right here is a circuit board, a solar charge controller that I bought from eBay. These are about $15 or so. And I use these I built a little Go Box solar generator thing. And this is hooked up inside of here with my 10 amp hour. So all of this crams into that box. And then, where are we? This top power pole that's got the little sun, that's the input that goes through this. These are pretty noisy. I've got one of these inside my G90 Go Box as well. And when you plug it in, boy, do you see that noise floor rise. So
yeah.
I was charging some batteries outside before I moved down to Texas, and I just left them out there just to play with them and just to experiment with the solar panels. And I was on my 7300 inside, totally not connected or anything. This was the battery was fully charged that was hooked up to this, and I would just see this RFI going across the screen on my 7300 from like 15 or 20 feet away. This thing was putting out all that noise. So be careful with the cheapos. I mean, I still like them. I can hook the 100-watt solar panel up to this, but don't play radio and have this thing charged. And I need to find a better version of this for the Go Box, because I want to be able to charge my batteries and play radio at the same time with the G90. So you pay for what you get.
Yep. There was a question in the chat that's very similar to this about RFI and power converters, and it's very hard to find cheap components that are RF quiet. Yeah. And solar in particular is very expensive. So if you get an RF quiet solar controller, which is like a Genasun or something like that, those are $140, $150 each. But they're proven. Julian had them on his channel. He just shows them integrated into his battery boxes.
Yep. He just switched to that buddy pole one too.
Yeah, and that one
so
too.
That one apparently is good.
RF quiet as well. That's a great one, and that's on my wish list.
Jason KM4ACK is using that buddy pole as well. So there's a couple guys out there that are using them that you can check out their videos and kind of see.
Yep.
So
Yeah.
In terms of panels, I've tried all kinds. I've tried cheap ones that I could find and eBay ones that are no name brand. And then I also have one of the smaller power film ones. And solar is expensive. That's kind of the bottleneck for me, is that I want a nice 100-watt foldable, but I can't find anything beside power film, basically. And power film is a $1,600 solar panel. So it costs more than basically my rigs and my battery build just on its own. And
I really like the BioNO 100-watt panel. It's nice.
Yeah,
They've got the foldable and but
Have
the power film I'd love to have, but good
you
God.
have the Mike, you have the BioNO 100?
Yeah. I've got the 100, the
And it's
60,
RF
the
RF
40.
quiet?
Oh yeah. Oh yeah.
Excellent. So that's another option too.
With not this BMS, but with the BioNO BMS, absolutely. Yeah, it's fantastic.
So solar is kind of my pain point at this point in my my builds. I have a bunch of RV panels similar to the one Mike has behind him, and I have a bunch of folding ones, but they're very weak. They're about 20 watts or so. So someone who wants to really be off grid and operate for a long time, they have to spend a lot of money on the solar portion of that.
Yeah. Have you seen? I think you have, Dennis. You've seen Gaston's the Tech Peppers hand cart thing. You were talking to me about it. I just saw. I was over at his house actually, and he showed it to me yesterday. And man, that thing is amazing. It's a LiFePO battery. It's 100 watt hours or 100 amp hours. 100 amp hour battery. He says he can like run his refrigerator off of it for like days, and he's got like a 300 or a 3,000 watt converter, and it's all on his hand cart, and he just kind of wheels it wherever he wants and powers whatever he wants. It's really cool, and he has plans to like
make coffee with it.
All day, man.
That's what he does. Is he always makes coffee with it.
Yeah. I wish he had time to come on and talk a little bit about it, but. Anyway, I guess why don't we just wrap it up here, and Dennis and Mike, why don't we go to Dennis here? Is there anything else maybe that we haven't talked about, or that maybe you want to talk about regarding batteries? Just kind of a free for all, anything, and then we'll go over to Mike after you, Dennis.
Yeah, I think it's a great time to experiment with these things because all the components are pretty cheap right now. So I really encourage people, look more into it, get the cells, get the BMS, get the nickel strips and the wire and the solder and all that. Try building one because in all honesty, I remember 2017, it was all about AGM batteries. That's what everyone had, right? And 3 years passed, 4 years passed, and now everyone's on lithium iron phosphate. I'm thinking now's the time to mess with this chemistry when it's cheap, because something else is going to come out in several years and all the hams are going to switch over to that. Who knows what chemistry it is, but I know that it's really being driven by the electric vehicle industry. They're looking at different other ways of powering things. And I'm pretty sure that they're going to come out with some like really mind-blowing thing that everyone will switch to. It'll be like size of a deck of cards and power your radio for 2 weeks or something like that. I don't know.
Can't wait.
But now's the great time to play with this stuff because it's getting very inexpensive. The battery hookup always has these specials that I'm always watching their Twitter for whatever they're posting. And they sell a lot of really inexpensive batteries. They're a couple dollars a cell. And it's very easy to get those pieces. The only thing is I buy a lot of stuff from AliExpress. So, of course, it takes like 3 months for me to get something that I'm checking out. I'll forget that I ordered something, and then suddenly it'll just show up at my door, and I'll be like, oh, okay, let's try this out now. Totally forgot about this. But yeah, I encourage people, check it out, try it. You'll feel really great going out in the field operating with a battery that you built yourself.
Cool.
Absolutely. And I want to touch on something that I've seen a couple people mention, and it was in my background. I'm going to, yes, everything Dennis said, build your own, learn about them. If you're going to buy a battery and have high expectations, buy from a reputable dealer like Bioenno. This battery right here, this Miati, I paid $50 for this. It's a 16 amp hour lithium iron phosphate battery. Guys, these batteries suck. Okay. They're horrible. I mean, it'll get you on the air. Okay. $220, $50. Why do you think that is? The BMS is not rated for a very high output. They're grade B cells. Watch Will Prowse's teardown video on those. I was actually on a live stream one time and I mentioned those, and he actually ended up buying them and after that and did a live stream because of that. So that was pretty cool. But they're junk. They're Chinese garbage. Will they work? Yes. Did I get most of the capacity that was advertised? Yes. Can I run my 7300 at 100 watts off of it? No. Well, maybe on sideband. I keyed down on CW at 100 watts, and my radio was only getting about 70% power out. So lower your expectations with those Miatis, boys. I know they're cheap. I'm probably going to buy another one, honestly, because I want to make a battery box. So I'll have a 30 amp hour battery just to have. It's probably nothing I would ever take to run my radios, more just, if the power goes out or something, I want that capacity. Again, my expectation is low on the current draw, but yeah, I mean, it's, it's like you can get a cheeseburger at a nice cheeseburger restaurant, or you can go to McDonald's. They're both cheeseburgers, but what's the difference? So just lower your expectations with that Miati. So yeah, buy once, cry once.
Like it.
All right. Dan and Brian, do you have any other questions or anything else, any comments before we let the guys promote their channels and podcasts and all that?
Go ahead, Brian.
I was to say, not for me. I have my next build project. I know that.
What's that going to be, Brian?
I don't know. Maybe a battery.
Cool. Dan, anything else?
Yeah, I think this is a great project that most people can tackle, and it'd be interesting to go ahead and build one with USB port in it and stuff like that. So when you're up there on the hill somewhere and you need to charge your cell phone or something, or you need to use an accessory that operates off USB, you've got it right there. So it's a great idea. I mean, you won't really find that stuff commercially, and building one gives you options that you can make it to fit your needs.
Yep.
All right, Mike, where can people find you?
You can find me on YouTube. The channel is called K8MRD Radio Stuff, the most creative name on YouTube. And you can follow me on Twitter at K8MRD. No Facebook, no nothing else. That's where I'm at.
And your YouTube channel, for people who may not, I think everybody knows, but just in case people don't know what you do.
Oh, yeah. Well, so I talk about ham radio. I do with a heavy focus on antennas and portable operations. And I've done battery reviews, different product reviews, radio reviews. I've got a couple coming up. I've got a couple HTs from Radioddity that I've got to review. I've still got a Tar Heel antenna that I need to review that MFJ sent me. That thing's sweet. And I'll be building
quite a backlog there, Mike.
I know, dude. I've got to get at. Well, now that I have like 365 days a year that I can be outside and shoot.
Nice.
And hopefully start pushing things out a little. Hey, I just put out a video today that on an antenna that I got at 6:00 last night. Okay.
Yeah, you did.
But I've got a QRP guys NFED half wave that I'm going to build. Really looking forward to that. So yeah, all kinds of outdoors related ham radio stuff.
Awesome. All right, yes. Dennis, what about you?
Oh, you can find me on Twitter. That's where I'm most active. AD6DM, my call sign. And of course, I have the podcast. I'm actually recording this stream, and hopefully we can continue even after the stream, so we can talk more for the podcast. My podcast is called Hamdom Thoughts, It's on Anchor, but if you just Google or look up my call sign on any podcast platform, you will find it. Hamdom Thoughts by AD6DM. And we've been going for about 30 plus episodes now. And it's every week on Wednesday. So it's great discussions and sometimes some live streams.
Cool.
I don't YouTube currently, but I do have some videos up. And that's probably going to change when I start building more of these backup power systems. I want to get that on video and show people how it.
I just want to let the people know that you do have a fantastic couple battery videos. Your little box that you built. So yeah, go YouTube AD6DM. You'll see a couple cool things.
For sure. Yep.
Thanks.
Okay, well, I'd like to thank both of you guys then. Yeah, let's stick around after we end the live stream and talk just for a few more minutes for Dennis. But I just wanted to express great appreciation to both of you for coming on. It was a great favor for you guys, a real honor to have you guys on to talk about batteries. I think hopefully our viewers have benefited from it, and so many thanks to you. For me, I have coming up, actually I'm going to be out of town sometime here soon, going to Georgia, so I'll do an activation there. And then video that. Our next guest for for this live stream, the All Portable Discussion Zone, will be Stuart. He's out in the East Coast, and so he's a great. He just got his mountain goat recently for Summits on the Air.
Nice.
And so we'll have him, and then I am actually going to be on Jason's live stream on lunch, and this coming Wednesday for lunch. Jason is Ham Radio 2.0. So check out that. Lunchtime on Wednesday, I'm going to talk about how to get involved in learning CW. We'll have a discussion there on learning Morse code, and I'll talk to you guys about how I did it and some ideas. I've polled some people and talked to a few, so should be an interesting lunchtime live stream. So with that, I'm just going to say 73 to everybody, and thank you. Let's go around and let everybody say see you later then.
Y'all come back now here.
Yeah, everybody.
73.
Hi, guys.
7-3. Thanks a lot, Charlie. Great show.
Thank you.